Welcome. Today we're going to be looking at exponents and powers of 10. I did a little diagram here to explain what exactly an exponent is. We're looking at the number 10 to the 6th power. The 6 is kind of like an apostrophe number. It's an exponent, and 10 is what we call the base. Now, it's easiest to explain if I just write out what this means. 10 to the 6th power actually means 10 times 10 times 10 times 10 times 10 times 10. It actually means there will be 6 tens in the number sentence. So 10 times 10 times 10 times 10 times 10 times 10, we have 6 tens multiplied together, which equals 1 million. There's actually not so much a trick, but the exponent, only when our base is a 10, the exponent will tell us how many zeros. If you notice, our exponent is 6, and we have 1, 2, 3, 4, 5, 6 zeros. So again, one last time, just to remind you, the exponent tells us how many tens will be multiplied together in that number sentence. Like I said, in this case, 10 to the 6th power is 10 sixes multiplied together, which gives us a 1 with 6 zeros. I gave us a few problems here for us to work through and try. First, we're going to start with 10 to the 3rd. Now, the multiplication problem would be 3 tens being multiplied together, which gives us a 1. And again, I mentioned that our exponent will tell us how many zeros are in our answer, and it will be 1,000. If you have 10 times 10 is 100 times 10 is 1,000. We come down to our next one, 10 to the 5th. We will be multiplying 5 tens together and getting an answer of a 1 with 5 zeros. Don't forget that exponent does help us out. And let's take a look at this one. Now, everybody always looks at this one and says, wait a second. So there won't be any tens multiplied together, so I can't really set up a number sentence for us, but it will be a 1 with how many zeros? Well, let's look at our exponent. 0 zeros. So a 1 with 0 zeros is just a 1. So 10 to the 0 power, though it may look a little odd for us, equals 1. Now let's take a look at this problem here. We have, I have my powers of 10. Okay, they're not going anywhere. There's my powers of 10. And then I'm going to add one more level of difficulty, if you will, and we're going to multiply them. So really, if we look here, this is going to be 2 times a 1 with 3 zeros, which equals 1,000. 2 times 1,000 is 2,000. We come back, we look at 4 times 10 to the 5th power is 4 times a 1 with 5 zeros, which equals 400,000. And lastly, here we have 23 times 10 to the 2nd. Our math problem would be 23 times 100, which gives us 2,300. Now, if we come back here and look at this, we actually can see a little problem forming here. So it's kind of like, if you look here, it's going to be 2 times 1 is 2 with 3 zeros. And then here we have 4 times 1 is 4. And then we just tack our zeros on at the end. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. And you can see we do the same thing on the last one here. That's our comma. We get 23 times 100 equals 2,300. Let's take this number. If you look at this number, it's 9,243. All right. Let's talk about expanded notation. So if we break this up, it would be 9,000 plus 200 plus 40 plus 3. This is how you've been doing standard notation probably for a while. This is probably the only way that you thought existed until now. Now we are going to take some of what we've been talking about here, and I'm going to show you how we can actually do expanded notation using powers of 10, which as you deal with bigger numbers, it'll actually save us some time. So check this out. 9,000 is the same as doing 9 times 1,000 plus 200 is 2 times 100, plus 40 is 4 times 10, plus 3 is 3 times 1. All right. So we have our 1,000, we have 100, we have 10, and we have 1. So check this out. So now we are going to start off the same. It is going to be a multiplication problem 9 times, but rather than saying 1,000, we could say 10 to the third, because 10 to the third is how you would write 1,000, a 1 with 3 zeros, times 2 times 10 to the second, which is a 1 with 2 zeros, plus 4 times 10 to the first power, which is 10 is a 1 with 1 zero, and lastly we could do 10 or 3 times 10 to that weird one, which is our 0 power, which really just means 3 times 1. So take a look at that. You used to probably think that this was the only way to do expanded notation, but now we can see how we progress through everything here. It started from this number, we came down here, okay, then we split up. Really, what does 9,000 mean? It means there's 9,000s and 200s and 4 10s and 3 1s, and then from there we took those thousands and hundreds and tens and ones and we turned it into exponents. So if I go back and underline what we had in red up above, they're the same thing. Before we end this session, let's go back and do a little bit of a review. First, let's start with just a power of 10. Again, the 4 is our exponent and 10 is our base. Now 10 to the 4th power means that we are going to multiply 4 10s together, which gives us a 1 with 4 zeros. And then let's move on down. We're going to apply that powers of 10, and you could turn that or use that in a multiplication problem where we have 23 times 10 to the third, which is really 23 times 1,000, which gives us the answer of 23 times 1, which is 23, and tack on our zeros. Now I was debating this whole presentation whether I would show you this, and I've decided I will. When we look here, a common mistake. Whenever I see a mistake with powers of 10, here it is. And I don't like showing, I'm scared to show you because I don't want you to make this mistake, but I feel that it's necessary. Sometimes what kids will do is they think 10 to the 4th equals 10 times 4. And I'm not even going to finish it. I'm going to use red, and we are going to cross that thing out. We're going to just say no to that. Okay? No. That is not what 10 to the 4th means. Refer to what we wrote in the green earlier, which is 10 times 10 times 10 times 10. The 4 tells us how many 10s will be included in our number sentence. Good luck. I hope this helps.